interdisciplinary. And yeah, so we'll be starting off with the code right now. Just give me a second. I'll just share my window with you guys. All right. I think my window should be visible now. Okay, great. Okay, so I'll be taking this right to the top here. So yeah, so we'll be sharing. I think the collab file will be shared with you guys in a few minutes now. So to start off, we are going to be working on this Melbourne housing data set. It's quite popular. The other alternative to this was the California housing data set, and it's been overused. So I thought it's best to switch it up a bit and go ahead with this one. So you can read all of this info, but I would like to take you to the Kaggle page for this. So I hope the Kaggle screen is visible to you guys. Right. Okay. So basically, this data has been collected by Tony Ping. He's a proper popular data scientist in the community as well, and majority of this data has been scraped by web scraping. So that's an important concept when it comes to data collection in general. So before that, before we start actually diving into the project further, I would like you guys to understand as to what all we'll be covering here. So the data that you'll be working with is basically a housing data set. So what all kind of stuff would you have? You'll have the seller, obviously. You'll have the type of houses. You'll have the date it was sold, the distance from the town hall, the region name, where it is exactly, the property count, basically the number of properties that exist in a specific neighborhood, the number of bathrooms, the number of garages or car spots, basically, the land size in general, the entire area of the house, the year built, and the council area, as in the town hall, again, as I mentioned, and latitude and longitude. Okay, now many of you guys, obviously, you have already passed your 10th, and let's say you've already covered geography in general in depth, right? So, latitude and longitude is basically a coordinate system for a globe, correct? So, basically, let's say this is basic stuff that we had done during our 5 days. We installed open data sets, then we obviously utilized this Kaggle link to log in and used our API key. You can download it as well. I hope you guys are already familiar with that. Next, we obviously loaded our Pandas data frame, and yeah, we just took a general overview as to what we have here. Next up, firstly, I checked whether, of course, there are some null values, and sure enough, there's quite a lot of them here, right? So we'll be working around that as well. And as you can see here, we have quite an interesting data set, to be honest. We have objects, int values, float 64. Float 64 obviously is something we've worked with quite a lot. And the object values will be more of the categorical data that we'll be covering. Next up, we have describe. All of this has been covered, right? So now, like I mentioned, we have latitude and longitude here. So just to proof check whether our data is real or not and how accurate it is, we'll be plotting the map basically. So can someone tell me what longitude is? Are they the vertical lines or the horizontal lines? Many folks have this confusion.
Vertical.
Perfect. So if they're vertical, what axis do you think they'll be on? The x-axis or the y-axis?
Why?
Y.
Why?
Y-axis.
Egg.
Why?
Okay, now that's a basic mistake. See, if longitude is vertical, it has to be parallel to the y-axis. Am I right?
Yes.
So, by that sense,
X axis.
longitude will be on the x-axis. Does that make sense? Or should I repeat it?
Yeah, it makes sense.
Yes. All right. So, likewise, latitude will be on the y-axis. So now when we plot this, we get this. Okay, so I'm not familiar with Melbourne's map. So I went online and proof checked, and sure enough, it does match. It's quite similar to the shape that we are seeing here, right? So yeah, basically the data set we have is quite accurate to the original Melbourne map. and whatever we'll be working on has some prior background set to it beforehand. Right. Now, okay, we have our map here, but our job is not to plot the map. Our job is to figure out what is affecting the prices of houses in this country in a specific neighborhood, and which neighborhood in general has a higher price range or is sold at a higher price compared to the rest. So, for that, of course, what I'll be doing here is I'll be utilizing our data frame directly, and I'll be plotting the longitude latitude. Same map as it is here, right? Same plot. The only difference I'll do is I'll use this color depending on the prices, right? Alpha is how light it is. I'm sure we've already done that. C map, we had covered it. Scatter plot, color bar. Okay, now color bar is basically to show the distribution of the prices in case you folks had not covered it earlier. And grid is just to show the grid. Now, when you look at this, are you able to understand what's happening here with the prices? Not quite, right? It's too dark, it's too close to basically understand. If I zoom in, is my screen being zoomed in?
Yes.
Yeah.
Okay, perfect. So
Yes.
sure enough, you can see some light and dark spots, but that's not enough to understand what's happening with the prices here. So right, once you've already collected your data and had a basic understanding of how it works, the next step is to try to make it usable. Now you have your prices here, but they are in a very awful range. They are like from 1 to 10 million. And that's a pretty big range to work around with. So our job is to basically scale it down. What I mean by scaling here is you will be basically utilizing this class called min-max scaler. So what min-max scaling is, wait, let me show it to you once. Let's say I run this. I've already run this. So workable data frame, and I show you varied dot head. Right. So as you can see, this is okay. Let me go a bit more. Let's say I just print it all together. So as you can see here, most of our values have been scaled down and they lie between the range 0 to 1. Now, this would traditionally, when you're applying this tends to help a lot of folks to actually find out that range in which your actual values lie. However, when I plotted the scaled price, what I found out was there wasn't much of a difference, right? It's still the same plot. So that means the values are quite close to each other. They are not in the traditional sense vast and quite usable. So then that left me with only one choice, right? Let's say you're sitting in a class, right? Your class in an informal sense is divided into three classes. First benchers, these guys score a lot of marks, they'll be sitting ahead. The average folks would traditionally sit in the middle, and the backbenchers who could be smart traditionally. I mean, obviously, most of you guys would have the sense that they're pretty complacent and are not interested in studying. But then, if they're smart, then they're considered outliers. But in the traditional sense, you can sort them into these three categories, right? So that's what I decided to do, and I utilized that as well here. Before that, obviously, it would be wise to drop the null values that we have here. And so, yeah, after that, after we've dropped our null values, I decided to cluster it. Okay. Now, what you mean by clustering is basically dividing a.
अरे मम्मी मारो मत, मैं अटेंड कर रहा हूँ लेक्चर यार, मारो मत मम्मी, मारो मत। अरे
Okay, I would request most of you guys to mute your mic unless you have an sincere doubt. Right, so I'll go ahead with this. So I'll just explain what this code is doing here. Q cut. Q cut is basically quantile cutting. So what you mean by quantiles is basically the classes you can divide your data set into. So you have your price column here, And what I'm doing here basically is I'm dividing the entire data set into 6 classes. Okay. And these 6 classes, we'll be utilizing that to plot here. So now when you look at this, you're able to get a better idea, right? So if I check out the coastal area here and this internal region right here, what this is showing me is, so it's been allotted to cluster 5, right? So I'll just show you what the individual clusters are. So if you see here, cluster 0. So this basically, where is price here? Yeah. So here we have price. So this comes in the range of around 300K. Likewise, cluster 1 comes in the range of 700K. Follow that up with this, and you'll be seeing that most of our values are increasing as the cluster number is increasing or cluster score is increasing. So cluster 5 has the highest price basically. So what that means here, as per this plot, is that this specific case here or this region right here, this middle region, has the highest price range. And that is asserted by the fact that these specific values here have a lower range. So this tends to give us a better idea as to how geography and how latitude and longitude plays an important role. So let's say Australia is in the technically almost in the southern hemisphere. So if you go to the coast, it will be affected by, let's say, wind currents, and it has a mediating climate which is suitable for habitation. If you're going down south or down north, you'll have contrasting climates as well. A small change, but quite significant when it comes to being habitable. So that this is what data science is all about. This is basically making numbers speak sense, if that makes sense in general. So that's what all this is about. Right. So now you have a general idea about the clusters and all of that. Now, so we use latitude and longitude. The next basic sense that would tell us is to check out the other columns, right? But before that, I would like to know if there are any doubts so that we can hear more from you guys. Any questions, doubts in general? Let's check it out once. Actually, I had a problem in the code. It was showing an error. It is... You can download it as well, Sanika. Just check out that Kaggle link if you're having issues. But I would recommend going through our old recordings so that you try to understand how OD works, open data sets. Okay, if there are no doubts, I'll go ahead now. Right. Once we have that in place, we will follow up with the scatter plots for each and every column. So, one second. That's a lot of columns, right? So, let me just show you one thing. Workable data frame dot columns. Right. Now, if we do len for this, basically I'm trying to find out how many scatter plots we'll have. So 23. So 23 into 23. So that's about 529. Am I right? Right. Okay. So you'll have 529 plots to plot here. So what I'm doing is basically I'm taking all the numerical attributes right here, and I'm utilizing the columns in those attributes and plotting them against one another. So if I start off with the scatter plot of rooms versus price, I'll see each room has this basic concentration. So this is not quite making sense, right? So I'll try to go through each and every plot and try to understand which plot would make sense for us. Okay, this is a slightly decent plot. So as you can see here, this is a scatter plot of the price and the distance. So let's say this is on the y-axis, you have your distance, right? So as the distance increases in this range, right, in the lower price range, it doesn't really matter. So which makes sense, right? If you're getting a house for a lesser price range, I would rather stay there and actually live my life out traveling more if I have to. Mumbai scenarios, obviously, if people of if most of you guys are from Mumbai or any high density city, so that does make sense. And going forward, as you can see here, as the price is increasing, there is some comfort factor as well here, because this is quite empty. So basically that means is these guys have prioritized a life of comfort, or they've spent more on their house so that they would be able to travel less. So yeah, the data speaks. Right. The postal code, this is a quite weird scenario here. But okay, not quite important, but nice to know that most of the postal code lies in the region 3000 3200. All right, that would might be helpful in some scenario. Again, bedrooms, not quite helpful. What could be helpful here is if we plot the bar graph. We'll look into that more later. Likewise for price and bedroom. Okay, that would make sense. Follow that up with cars, land size, building area. Not that helpful here. Okay, so see, like we saw earlier, in the mid region, in the middle region of the latitude, the price is quite varied. We have our lesser priced folks and the higher priced folks, but most of the higher priced folks lie in the middle region, which fits. Likewise for longitude, almost similar. Latitude and longitude are almost similar when it comes to the relation. Then the property count for each price. Now, this is quite varied. I wouldn't go for this if I were you, especially as a beginner. Okay, price versus varied price. Obviously, we had made a scaled price column, right? So, obviously, they have to be directly related. Likewise for cluster. So now after some point, distance versus car is not helpful, because right now we'll be focusing on price. So you can check out the other plots here as well. I won't be going into detail here, but yeah, that was basically the major crux of plotting it. Now before we go into anything else, I'll try out the bar plots as well once, just so that you guys have an idea. Let's say we plot our bar plot, right? Or you know what, before bar plot, I would rather show you the correlation matrix so that you guys have a better idea as to which columns are better related. So as you saw, this was quite tedious, right? Going through each plot, trying to understand which relation is related, or which columns are have a higher relation coefficient. Rather than that, you could simply build a correlation matrix. So this is a really important aspect of pandas. So dot core basically is to build a correlation matrix. You can read this up later, but in the general sense, it's basically a relation coefficient has been utilized to try to understand how closely related two parameters are. So their values will lie between -1 and +1, obviously, negatively related and positively related. Now, we have a correlation coefficient here, but to make a better use of this, you would be utilizing your heat map. Perfect. So now this makes more sense if you see it here. Right. So the darker ones are basically negatively correlated. And from this, you can identify a couple of things beforehand itself. So let's say this darker one right here. So the here build is inversely related to cluster, right? So let's think of it this way. Cluster 5 basically had higher price values. Am I right? So let's say if higher priced values are negatively related to the here build. So in that sense, price, which is about varied price, should have it, yep, right here. So that is again obviously negatively related to the here build. Okay, that fits, right? So let's say you have an extremely old and a broken house, you wouldn't go for that. Am I right? So you would go for a relatively newer house with better architectural practices, following baseline principles of modern architecture. It fits, right? So this is where we basically try to understand the data. Likewise, if I try to find something else which has a higher relation, so rooms and bedroom are related, obviously that fits as well. Okay, let's see here. Okay, so let's see here. Bedroom and price have an almost positive relation, 0.43 and bedroom. So that means higher number of bedrooms directly correlates to the price. Fits, right? 2 BHK houses cost less than 5 BHK or a 4 BHK house. So yeah, that's all fine. That's all good. Perfect. So we are building up a base with numbers by itself. Now you would be like, why do we need this? We already know all of this. But trying to get a better understanding with stats helps us more when we are predicting values in the future. You'll know more about that by the end of this session. But yeah, okay, now we'll be plotting some more graphs, something that would give us a better idea. Okay, so these are the two types that we have in our house. So let's say if I go here, right, see. So we have something like this. We have house, cottage, villa, semi terrace, unit, duplex, townhouses. So from here it's become quite evident that this one and these three basically have not been utilized at all in this data set. So this description needs to be updated. What we're understanding from this data is basically most of the houses there are duplexes, townhouses, and cottages and villas, which might not be true. So basically, we got our first bias or a disadvantage in this data set, that it's not covering every class of an Australian country. Basically, they are not being able to understand or cover all the minorities or the majorities completely in this data set. So that's something you can do to update this specific data set as well. And yeah, that's not what we'll be covering in this specific session, but that's an important aspect as well of data science. Perfect. We come back here and obviously we plot our trusty graph chart. And yeah, so from this you understand that most of the houses in this data set are villas. T, what was T again? Let me go back. Townhouses. Makes sense. Townhouses are less in number. They are basically your district houses, basically the government ones where you have your community meetings and all of that. So yeah, that fits. And sure, of course, some menial number of folks will have duplexes or units. Okay, that fits. Now we'll come to our bar plot, and I saw a significant relation between price and the year built, right? So I utilized this bar plot here to try to understand how well related the price is with the year built. So as you can see here, let me zoom in a bit here. Right. So one second, let me. Okay. Yeah, that would be slightly better to view this plot here. And as you can see, this one in particular is the highest one. You can see, and if you basically let me zoom in a bit, give me a minute. So that's the price. That's 5K. Now, if we go down here along this here, and that is your year 1884. So basically, the year 1884 has the highest or the maximum price range. So basically, what we're understanding from this is that our price range might be directly related to the year, but there are certain years that have a specific interest, that has caught a specific interest in folks in general. But now let's try to understand what these lines are. I hope the bar plot is visible. I would again recommend you guys to be sitting with your laptops instead of your mobile phones. So I hope there's no issue till now. Any other doubts before we go ahead?
No.
Perfect. I hope you've understood everything till now. Right. Now, once you have that in place, I decided to plot a line plot as well. So, the most basic understanding of plotting this specific data set or trying to collect this data set was basically you had to find out where was the price slowing down. Right. We've already covered this. How does the council region affect the prices and the number of houses sold? So the basic idea behind this was try to find out where the market crashed for houses or the real estate market here crashed. So if you see here, everything was decent to some extent until we reached here. Right. So if you check the price here, it could be something pretty close to 1900s. And I have a strong feeling, a gut feeling that tells me that basically if we go back here to 1884, so I have a feeling that the priciest houses would be right here where the market value crashed. So they were sold for less, but over time their market value grew, which fits again. So basically, this is trying to relate your data with real world aspects of how you could apply it. So that's the basis of this project. And I hope you guys have a general idea for now. Now we'll be having some general plots before we actually get to the machine learning aspect of it. Right. Okay, so yeah, this fits again. You will have your rooms in general here, where obviously the larger number of rooms, the greater the number of rooms, the more is the price. Interestingly, this specific number here has a sudden drop. Oh, sorry, did I cover why we have the lines here? Sorry, my bad. We'll go back up once again. So the lines here, basically, they are depicting the length of how much varied your data set is. Let's say you have values from 1 to 100 in category 1, and let's say the other let's say room number 7 for example has 1 to 100 prices. Okay, room number 12 will have a higher variability. It might start even lower or go even higher. And this line takes into account the number of houses as well here. So a it's basically a ratio between the frequency and the variance of that class. I hope many of you guys are familiar with variance. If you are not, we'll cover that as well. Anyone who's not familiar with variance or standard deviation? I'm pretty sure most of you guys were from stat background, right? Earlier.
Yeah, Vedant, but I'm quite confused about variance and covariance. So if you look at once, it will be
Right,
helpful.
right. Okay, so covariance is more of a relation between two specific attributes. So let's say, okay, I'll give you a better example here. So you saw a heat map, right? There was a coefficient, correlation coefficient given to it. So like for cluster, wait, let me go back to our heat map. Oh, sorry, my bad. Okay, right here. So this here built and a cluster have a negative relation. Likewise, rooms and a cluster have a positive relation. So this is where covariance comes into picture. That is to try to understand how different the scaled values of two different columns are related to one another. Does that make sense, Mangesh?
Yeah, yeah.
Okay, so there it's more of a thing of comparison, whereas variance is for a specific column, a single column,
Okay, so covariance is all about how one value change according to a different
another.
value.
Perfect.
Yeah.
Yes,
Okay,
exactly.
okay. And yeah, thank you.
Yeah, welcome. Okay. Right. So we've covered these plots now. This is quite similar. You just have to go through it. This is another plot which I tried to do, and it was not possible.
Vedant,
Yeah.
I guess someone has some doubt. Just clear it now.
Haha. Okay. Please explain the black line concept again. Okay, sure. So, firstly, Shreyas, I hope you understood variance and covariance, the doubt that Mangesh asked right now. Is that clear to you? Yeah, okay, perfect. So, if that is clear, so basically try to understand this. The length of that black line is a ratio. Basically, it is this variance divided by the number of values present in that column or attribute or that specific category. Let's say I'll take an example for you again. Abhi, let's say a house has 8 bathrooms. Its length is higher. Basically, what this is trying to say is the ratio between variance and the number of attributes in this specific category is quite high. Basically, what could be happening here is either your price for a house that has 8 bathrooms is quite high compared to the number of houses that have 8 bathrooms. Does that make sense, or do you want another example? Cheers. Any queries as of now? That's basically how that length was. So that rather than the concept of the okay, more another example. Okay, perfect. I'll do that again. All right. You have bathrooms. You have okay. See, basically this is more of you know what? 1 second. Let me check if I can get something better here for you guys. Uh, okay. Instead of price, let's see if I have something else here in our workable data frame dot columns. Okay. Let me zoom in a bit. What can we take? What can we take? Okay. Seller. Perfect. We have seller G, if I'm not wrong. Okay. Okay. Wait. I forgot to change the labels here, but we'll cover that as well. Give me a minute. Let it run a bit. No. Okay. This is quite varied. Okay. We can't work with this. A lot of values here. Uh, okay. Let me think of something else. Let's go for car. I won't change the labels, just try to understand the data for once. Perfect. This is slightly better. Okay. So think about it this way. The number of people who would have 8 cars, right? The number of people who would have 8 cars would be quite less compared to the people who have 1 car. Am I right? Does that make sense? That fits, right? Perfect. Yeah. Did someone have a doubt? Someone raise their hand. Yeah, okay, perfect. Yeah. So the number of people that would have 1 car compared to 8 car would be less. However, the price for a person who has 8 cars, price as in the price of the house. So basically, what we're doing is we're trying to relate the number of cars a person has with his house, right? So clearly, a person who has 8 cars would need a bigger house. So, in that sense, this category of people is quite less. So, what I'm trying to say is the price for that house will be quite high and the number of people would be less. So, going back to our ratio right here, that is variance. Basically, the price of that specific price of that house that is holding or withholding 8 cars would be quite high compared to the median divided by the number of let's say people that can afford that cars, those number of cars is quite high as in like the variance is high. Basically it's less common and more rare. That's what it is all about. It is a measure of rarity, a measure of uniqueness. Does that make sense? I hope you understood that. Shares, it's not exactly variance, it's divided by the frequency also of that category. So ठीक है, एक बार शॉर्ट में बताओ, वेरिएंस लो अपने कैटेगरी का, कितना प्राइस डिफरेंस है मीडियन से, एंड उसको डिवाइड करो जितने लोग हैं वो कैटेगरी में से। अगर वो ज्यादा आता है नंबर, तभी ही तुम लोग का लाइन लंबा रहेगा, नहीं तो नहीं रहेगा। रेशियो के ऊपर है वो। आई होप दैट्स क्लियर अभी। परफेक्ट, ठीक है, आई होप दैट सॉल्व्स इट। ओके, now we're almost getting close to the ending. Okay, just see this also once. This is an important thing. So you have several real estate companies, and the top sellers that you'll find will be Jealous, Nelson, Marshall, Barry, Hawking Stewart. So these are basically Australian companies. So I would definitely prefer a house that is sold by Jealous, because they clearly have a higher selling rate compared to the other companies in this data set. So this is where, let's say, a client has to reach out to a specific company. This kind of statistical distribution is what helps them, and this is what will nurture a healthy relationship between the company and the client. So that's that. Now, finally, we've come to the ML aspect of it. So now it's gonna get pretty heavy. So buckle up now. We are going to delve into a lot and lots of maths now. Okay, so linear regression. Does anyone have any general idea as to what linear regression is? Could you cover? Could anyone just say what they think of linear regression in general? What do you think is the basic concept or the idea behind it? A line that covers more points. Perfect, Rashmi. Perfect. Finding the best fit line. Right. So basically, you'll have a line that shows the general trend of your data points. That line is basically an estimation of all your data points. So that finding that line is basically the algorithm that's known as linear regression. Sure, yeah. Okay, right. So now here's where things get a bit interesting. Do you think linear regression can be done with, let's say, four columns with only one target column? Like, I want to find price, right? So let's say I take bedrooms, bathrooms, area, and the number of cars. Let's say I take these four columns. Can I find the relation of all four of these together with respect to price? Do you think linear regression can do that? Yep, sure. Yeah. Now that's where things get a bit interesting. You can make it linear. I'll show you now. Okay, so let's get into it. Okay, so simple linear regression is what you guys have a clear understanding of. That's basically taking your price and the year built, right, and trying to find a general plot of it, and trying to understand key. Okay, I have two columns, and let's see how much, what is the trend in this specific date, in these specific data points. So, ठीक है, you have a general idea of all of this. So this is the mathematical equation. So I'll show you this before we actually get to it. So B naught na abhi, wait, let me Google linear regression ka plot for you. Or you know what? I'll show the plotted one only here so that you guys have an idea. ठीक है, you see this one? I'll show you how we came to this. But before that, you see this line here, right? If I extend this line, उसका y intercept तो होगा ही, correct? Every line has a y intercept. At some point, it has to actually intersect into the y axis. So b naught, अभी यहाँ पे if you go a bit more up, yeah, b naught is basically your y intercept, and this beta 1, b naught or beta 1 is b1 or beta 1 is basically your slope with respect to the other column. So as Shaurya perfectly mentioned, Shaurya or Shreyas, I forgot, Shaurya, you will take two columns and plot them against one another, and you'll take uska slope of that line. So this is that. However, you'll have an error term. It's not necessary that the first line that you take about those data points is accurate. So we will utilize something known as an error term to get the line of best fit, as someone had previously mentioned here in the chat. So yeah, perfect. Simple makes sense. But then again, as you guys mentioned, right? How can we take multiple columns and actually utilize them to get, a general plot for us? So you saw that the slope of each of the second column was taken into consideration while plotting the line. Correct? अभी तक सब ठीक है ना? Yeah, Shubham, perfect. Yeah, yeah, right. अभी तक सब ठीक है. Perfect. तो let's say I take ऐसे slope and I take 4 कॉलम का स्लोप एक साथ यहाँ पे, just like this here. And if I combine all of these slopes, all of these coefficients, and then add the error term, then I will get a general distribution taking into consideration all 4 columns. Does that make sense? Or if you guys have any doubt, you can ask. Perfect. ठीक है. I don't think you guys have any doubts. Yeah, Shubham, perfect. Yeah, y is your dependent variable. You'll take a price into consideration here because that's what we're trying to find, right? Price of a house. Right. Abhi, you have a general idea of how to do this, but this doesn't make sense. How will you find B naught, beta 1, beta 2, beta n, and so on, right? So that's a major question. We'll come back to evaluation later. Before that, I would like to show you the formulas for this. Okay, so what are your first thoughts when you look at this? Does this look intimidating to you guys? Stat background, guys, you guys will be working with this for at least the next 3 or 4 years. So get used to stuff like this. So before that, I'll just cover a few of these for you guys. Okay, I'll zoom in a bit. Okay, dot product. I hope all of you guys who've already done 12th are familiar with. You'll have two vectors or two matrices. You'll do the dot product. You'll basically go element wise and add their products. That's your dot product. Same goes here. That's the formula. Okay, now linear regression coefficients. ये basically ये जो slope आ रहा था हमारा यहाँ पे if we go beta 1 beta 2, how will you find that? तो अभी ये xt and xt dot x, does anyone have an idea as to why we're doing that? Sorry. What do you think xt into? Yeah, sure, yeah, they are matrices. Why do you think you would do this? Like xt into x and xt, then you're multiplying it with y. Right, that's the, yeah, you have to think about it thoda sa. So see, abhi if you do x transpose and you're doing a multiplication of that with your base x, abhi firstly x kya hai yahan pe? X is the column whose beta you're trying to find, right? तो basically y मेरे prices रहेंगे and उसके हिसाब से मुझे x को into consideration लेना है, ठीक है? So that xt dot x उसका inverse करेंगे and when we multiply that with xt, so what that is doing is basically it's giving me a number. अभी if you think about this hard, this will give you a number. Coefficient आएगा ना, beta will be a number, it can't be a matrix. So this is to basically get the sole number which represents your entire pattern, right from variance, standard deviation, mean, median, everything into one specific number. And then you're taking your y variable into consideration. Determinant, it's not purely a determinant, but you could say that. Yes, so determinant is one factor that is being taken into consideration here. Perfect. आइगन वैल्यूज पता है सबको यहाँ पे चालू है एफ वाइज का? Will there be sadly अभी I could show you the code version but I can't show you the exact working पूरा. I could show you how what kind of coefficients you can get. आइगन वैल्यूज, आइगन वैल्यूज आइगन वेक्टर सुना है? नहीं सुना है?
Yes,
ठीक है,
yes.
हाँ शिवम करेक्ट, ठीक है। तो यू could सर्च मोर ऑन दैट डिटर्मिनेंट से ही you'll have to kind of utilize that later. See, you can search up आइगन वैल्यूज थोड़ा बाद में। बेसिकली आइगन वैल्यूज का मैं कंसेप्ट समझाता हूँ तुम लोग को। अभी इफ आई सी अ 2x2 मैट्रिक्स, मैं उनके नंबर्स देख सकता हूँ एंड आई कैन ट्राई टू फाइंड द डिटर्मिनेंट एंड ऑल ऑफ दैट। आर वी गोइंग टू यूज अ लिटिल बिट ऑफ एआई? नहीं नहीं, ये सब हार्ड कोडेड होने वाला है। आई एम गोइंग टू शो यू द मैथ्स बिफोर वी एक्चुअली यूज अ बेसिक प्री बिल्ट मॉडल। तो एआई वैसे इफ यू आर एक्सपेक्टिंग एलएलएम्स, इमेज कैप्शनिंग एंड ऑल ऑफ दैट स्टफ, वो तो उतने लेवल तक नहीं जाएंगे हम। बेसिक एक प्रिडिक्शन बेस्ड एमएल मॉडल बना रहे हैं हम लोग अभी। हाँ, तो आइगन वैल्यूज के कंसेप्ट पे आते हैं। मैं तुम लोग को शॉर्ट में बताता हूँ क्या है। अभी एक 2x2 मैट्रिक्स है, 4 वैल्यूज रहेंगे उसमें। उसमें देख के तो समझ जाएगा आप लोग को कि हाँ ठीक है 2x2 मैट्रिक्स है, इसमें ये वैल्यूज है। दिस मीटिंग इज, yeah, sure Mangesh, we'll share the recording on our WhatsApp group and even on the drive, so you'll have access to that. You can go ahead. ठीक है, सो बेसिकली मैं 4 वैल्यूज को देख के समझ सकता हूँ कि मैं व्हाट आई एम वर्किंग विथ इन दिस मैट्रिक्स। बट लेट्स से मेरा 20x20 वाला मैट्रिक्स है, इन दैट केस वर्किंग विथ इट इज स्लाइटली हार्ड। एंड अभी 20x20 भी नहीं है यहाँ पे, दिस इज लाइक ऑलमोस्ट 14,000 into 20, राइट? तो इन दैट केस यू यूज समथिंग कॉल्ड आइगन वैल्यूज, उसका भी अलग फॉर्मूला आता है, which basically let's say अगर तुम लोग का 3x3 मैट्रिक्स है तो you'll get 3, 2x2 है तो 2 आइगन वैल्यूज आएंगे, तो उतने नंबर के तुम लोग के कोएफिशिएंट्स निकलेंगे एंड दे गिव अ जनरल आइडिया एज टू व्हाट योर मैट्रिक्स कंसिस्ट ऑफ। तो बेसिकली इतना समझ लो अभी के लिए, एंड बेसिकली वी आर ट्राइंग टू फाइंड दैट। अभी ये सब कोड करने के लिए, हाँ हाँ सॉरी रेसिड्यूल सब मैं भूल ही गया बताना। मीन स्क्वायर्ड एरर, ठीक है, दिस आई विल टेल यू व्हाट दिस इज। अभी हम लोग प्रिडिक्टिव मॉडल बना रहे हैं एक, ठीक है, राइट हियर एक प्रिडिक्टिव मॉडल बना रहे हैं, तो इट विल प्रिडिक्ट सम वैल्यूज एंड वाई आई इज बेसिकली योर एक्चुअल वैल्यूज, जो एक्चुअल प्राइजेस है तुम्हारे घर के वो रहेंगे। तो अभी एक्चुअल माइनस प्रिडिक्टेड, डू यू थिंक दैट विल गिव यू द एरर? मतलब हाउ मच वी आर ऑफ बाय, कितना गलत है हम लोग, डू यू थिंक दैट्स अ गुड मेजर ऑफ दैट? इट इज राइट। If you guys want to comment, just let me know. हाँ हाँ, मीन स्क्वायर मतलब एरर एज इन हाउ फार वी आर फ्रॉम द एक्चुअल वैल्यू। तो बेसिकली इट्स अ मैथमेटिकल एरर, नॉट लाइक योर प्रोग्रामिंग वाला एरर। तो यस, तो एरर है वो। सो व्हेन वी स्क्वायर दैट एंड वी डिवाइड दैट बाय द नंबर ऑफ वैल्यूज यू हैव in your data set, that is when you get this mean squared error, and this helps you know how bad your predictions are, ठीक है? दैट इज रूल नंबर 1, मीन स्क्वायर्ड एरर। अभी आर स्क्वायर थोड़ा ज्यादा कॉम्प्लेक्स है। इसमें क्या होता है, दिस इज लाइक अपना सेम एज मीन स्क्वायर्ड एरर, ठीक है? यू विल टेक मीन स्क्वायर्ड एरर का फॉर्मूला विदाउट द एन, वो दिस जस्ट दिस मच पार्ट यू विल टेक समेशन ऑफ all the differences between the actual and the predicted values, उतना लोगे। एंड एक और लोगे तुम लोग, तो एक हो गया रेसिडुअल सम ऑफ स्क्वायर्स, दूसरा हो गया टोटल सम ऑफ स्क्वायर्स। दिस इज बेसिकली योर एक्चुअल वैल्यूज माइनस द मीन, एंड व्हेन यू make a ratio of these two values and subtract that from 1, that's when you get r squared. Now abhi ye sab this huge code that you're seeing here, wait I'll zoom it in a bit for you guys more. ये बड़ा सा कोड दिख रहा है तुम लोग को? दिस इज बेसिकली जस्ट अप्लाइंग दिस सेम फॉर्मूला, ये सब जितना भी किया है हमने, एंड दिस फॉर्मूला राइट हियर, दिस वन इनटू वन प्लेस। तो अभी मैं दिखाता हूँ। तो वी विल बी वर्किंग विद दीज फीचर्स फॉर आवर डेटा सेट। रूम्स लेंगे हम, बाथरूम लेंगे, लैंड साइज लेंगे, एरिया लेंगे, डिस्टेंस लेंगे एंड ईयर बिल्ट लेंगे, ठीक है? एंड अपना y होगा प्राइस। कुछ डाउट्स है? परफेक्ट, ठीक है। ओके, तो अपना y हो गया प्राइस। अभी हाँ, ये स्प्लिटिंग का कंसेप्ट मैं बताता हूँ। अभी कैसे होता है ना, दिस इज द मोस्ट बेसिक कंसेप्ट ऑफ एमएल। सो लेट्स से यू हैव 100 वैल्यूज, ठीक है। उसमें से अभी क्या होगा ना, तुम लोग जब मॉडल ट्रेन करोगे तो 80% ऑफ द डेटा यू यूज फॉर ट्रेनिंग द मॉडल। बेसिकली बेसिकली क्या हो रहा है, हम लोग जो ये कंसिडर कर रहे हैं ना, ये एक्स एंड वाई, इसका लेंथ जो होगा एक एक मैट्रिक्स का या फिर वेक्टर का, वो होगा 80% ऑफ द टोटल डेटा, सो दैट वी कैन टेस्ट 20% ऑफ द डेटा कैन बी टेस्टेड ऑन, एंड देन उस पे यू अप्लाई तुम लोग का एरर्स का ये कंसेप्ट टू चेक कि हम लोग कितना गलत है या फिर कितना सही है। दैट्स इट, दैट्स द बेसिक कंसेप्ट ऑफ स्प्लिटिंग दिस। तो हाँ, यहाँ पे अभी तुम लोग को एक नया मॉडल देखने को मिलेगा, लाइक पैंडास हो गया, नमपाई था। यू यूटिलाइज समथिंग कॉल्ड एसके लर्न, जिसका फुल फॉर्म इज साइकिट लर्न, that has a lot of your machine learning models and statistical models for understanding the data. So यहाँ पे हम लोग वो कर रहे हैं। I hope you understood why we're splitting the data. ठीक है, ओके, तो आई होप इतना समझ गया तुम लोग को। बेसिकली डेटा को स्प्लिट किया हमने। अभी यहाँ पे हम लोग ट्रेनिंग मैट्रिक्स बना रहे हैं, बस वही है अभी के लिए हम लोग ने ट्रेनिंग मैट्रिक्स बनाया। अभी हाँ, यहाँ पे तुम लोग का डॉट प्रोडक्ट का है, मैं डायरेक्टली नमपाई का डॉट प्रोडक्ट यूज कर सकता हूँ, बट जस्ट टू एक्सप्लेन टू यू गाइज हाउ टू एक्चुअली गो अबाउट इट, आई हैव डन दिस। आई होप यू गाइज विल अंडरस्टैंड इसको अच्छे से। ज्यादा कुछ नहीं है इसमें। बेसिकली तुम लोग अपना रेगुलर डॉट प्रोडक्ट कैसे होता है वही चल रहा है। एनपी डॉट जीरोज याद है ना तुम लोग को, रैंडम वैल्यूज लेता है वो इन इसमें से रिजल्ट में, इसमें से ये दो वैल्यूज में से। तो m1 इज योर x, m2 इज योर y, तो इसका y कोऑर्डिनेट, इसका x कोऑर्डिनेट, x y आ गया हमारा इधर। इन दोनों में से रैंडम ऑर्डर में हम लोग वो वैल्यूज लेंगे एंड उनका डॉट प्रोडक्ट निकालेंगे, एंड फिर हम लोग डॉट प्रोडक्ट को रिटर्न करेंगे। अच्छा, इधर क्या हो रहा है, np डॉट सम। आई होप ये समझ गया, ये अच्छे से देख लो एक बार। ओ सॉरी, ये देखना पड़ेगा तुम लोग को। np डॉट सम बेसिकली हम मल्टीप्लाई करेंगे। बेसिक डॉट प्रोडक्ट कैसे होता है, लेट से तुम लोग का 2,3 है एक में, ठीक है, एंड दूसरे में 3,4 है, तो 2 into 3 होगा, उसका 2 into 3 6, फिर 3 into 4 होगा, उसका 12, 6 + 12 18 करके you'll get your dot product. I'm pretty sure you guys are familiar with dot product. Basically वही हो रहा है इधर। तो हम this we do that for xtx and xty. क्यों? Because of this xtx xty डॉट प्रोडक्ट्स आ गए हमारे हाथ में, ठीक है। अभी यहाँ पे यहाँ पे मैं सीधा इन्वर्स करूंगा क्योंकि इन्वर्स का कोड लंबा जाएगा एंड आई डोंट वांट दैट कोड टू बी दैट लेंथी, तो आई यूज इन्वर्स हियर। देन यहाँ पे मैंने सीधा डॉट कर दिया सो दैट यू गाइज हैव एन आइडिया एज टू हाउ टू गो अबाउट इट। सिंपल। अभी यहाँ पे वी आर जस्ट डूइंग समेशन ऑफ दीज बेसिकली कोएफिशिएंट्स दैट वील गेट। ये देखो मैं तुम लोग को दिखाता हूँ, ये कोएफिशिएंट्स का वेरिएबल है। तो ये सब करने के बाद here are your coefficients, कितने, 1 2 3 4 5 6 7, ठीक है। you'll get 7 coefficients, 1 2 3 4 5 6, एंड एक तो प्राइस के साथ रहेगा एक कोएफिशिएंट, that will be taken into consideration as well, ठीक है। परफेक्ट। अभी ये तो तुम लोग का सीधा फॉर्मूला एप्लीकेशन है, जैसे फॉर्मूला था वही किया है मैंने। यू कैन गो थ्रू दैट। ये फ्लैटन एंड ऑल ऑफ दैट वी कवर्ड इन आवर ओल्ड पैंडास एंड नमपाई लेक्चर्स, जस्ट गो थ्रू दैट एक बार अगर समझना नहीं है कोड ये, एंड खत्म, उतना ही था। यू विल गेट योर कोएफिशिएंट्स। अच्छा, अभी ये देखो, ये एरर दिख रहा है तुम लोग को, मीन स्क्वायर्ड एरर. डू यू थिंक दिस इज बैड? यस और नो में बोल दो बस. ओ, गलत है, बहुत गलत है. लेट्स बी फॉर रियल. आर स्क्वायर के हिसाब से इट इज अ बिट डिसेंट. सो सी, it's got a general idea. So yeah, okay, one more thing. I have plotted our values also. So y test and max y test and min test and max y test अलग से मैंने प्लॉट किया है, सो दैट वी गेट एन आइडिया कि अपने लाइन ऑफ बेस्ट फिट क्या है. तो ठीक है, इट्स गॉट अ जनरल आइडिया कि हमारा प्लॉट कैसे. सो इफ यू चेक दिस आउट अच्छे से, यू विल अंडरस्टैंड को ये ऑलमोस्ट अपने सारे डेटा पॉइंट्स को बीच में से काटते हुए जा रहा है. एंड okay, what one more thing about linear regression is it line of best fit कैसे निकलता है. ये दिख रहा है यहाँ पे, ये सबसे दूर वाला पॉइंट, उसका हम लोग डिस्टेंस निकालते जाते हैं फॉर ईच एंड एवरी पॉइंट. तो द समेशन ऑफ ऑल ऑफ दोज डिस्टेंसेस with respect to that data point and that line, that from that you get your line of best fit. I hope ये समझा. ये थोड़ा heavy था, I'll repeat it. ठीक है, परफेक्ट. आई होप यू गाइस अंडरस्टूड लाइन ऑफ बेस्ट फिट का कंसेप्ट. तो ये अभी बहुत मैथमेटिकल था लीनियर रिग्रेशन के टर्म्स में. अभी एवरी टाइम यू आर रनिंग दिस ऑन एनी काइंड ऑफ डेटा सेट, ये थोड़ा लंबा नहीं होगा. ओके, द कोड आई डिडंट गेट बट आई गेट व्हाट यू मीन. हाँ हाँ, सो सी इट्स हार्ड टू गेट दिस कोड एट वन गो. तो आई वुड रेकमेंड दिस, रीड दिस 7 to 8 times. Read this 7 to 8 times. Try to understand what that formula is doing. Then relate that with whatever you've learned. Basically flatten क्या कर रहा है, mean क्या निकाल रहा है, inverse क्या चल रहा है. हाँ, तो basically वही है, भावनाओं को समझो. ठीक है. So that's what I'll try to say. Because see, these kind of algorithms took a lot of time to develop and they're pretty heavy. That's it. हाँ, शब्दों में थोड़ा तो जाना ही पड़ेगा क्योंकि सी लेट्स बी ऑनेस्ट, मोस्ट ऑफ अस व्हेन वी आर गेटिंग इनटू एमएल वी कांट ट्राई टू अंडरस्टैंड द मैथ्स between each and every concept because it's going to get heavier as and when you go forward. अभी linear regression चल रहा है, आगे जाके you will find heavier models which utilize tons and tons of maths. LLM सब यूज करोगे, वहां पे भी डिस्टेंस मेजर्स आते हैं, बहुत सारी चीजें आते हैं कंटेक्स्ट समझने में. तो मैथ्स में यू हैव टू सी, इफ यू आर डेवलपिंग अ मॉडल देन यस यू विल एब्सोल्युटली नीड टू अंडरस्टैंड द मॉडल का यूसेज एंड हाउ ईच एंड एवरी एस्पेक्ट इज रनिंग. बट दैट इज क्वाइट लेटर इन योर करियर और योर रिसर्च जर्नी. सो अभी के लिए ट्राई टू अंडरस्टैंड व्हाट ईच फॉर्मूला, ईच matrix, each data point, how it is being used. अभी के लिए if you are going heavy into maths you can always refer this. मैंने सब डाला है इधर linear regression में क्या हो रहा है. Whoever is pretty good with stats can obviously get a basic idea of what this code is doing. Easy है to understand once you are able to understand कि क्या आ रहा है हर एक चीज से, बट उसके लिए again you have to revise all your concepts एक और बार. सो दैट इज वाई ठीक है, अभी ये हर बार तो नहीं कर पाएंगे हम लोग. तो टू काउंटर दैट वील बी प्रेइंग टू साइकिट लर्न बिकॉज सारे एल्गोरिदम्स इसमें ऑलरेडी है. तो ये सब हमने जो किया हमें करने की जरूरत नहीं है unless we are actually going heavy into the maths. So we can simply call this class or this submodule from sklearn linear models. एंड बेसिकली ये वापस वो स्प्लिटिंग का पार्ट आ गया आपका डेटा सेट का, ये आपका मॉडल आ गया. एंड उसके बाद यू यूटिलाइज दिस फंक्शन कॉल्ड फिट. तो बेसिकली फिट क्या करता है, ये जितना भी हमने कुछ किया है इधर तक, मल्टी लीनियर प्रिडिक्ट से लेके इधर तक, इट विल रन दिस एंटायर एल्गोरिदम एंड देन इट विल ट्राई टू अंडरस्टैंड द वैल्यू. देन उस पे हम लोग टेस्ट वैल्यूज पे प्रेडिक्शंस लगाएंगे. एंड एज यू कैन सी मैंने जो कोड बनाया है ऊपर और यहाँ पे जो कोड है, दोनों के एरर वैल्यूज सेम है ऑलमोस्ट. थोड़ा सिग्निफिकेंट डिजिट्स में फर्क रह सकता है, लाइक यहाँ पे 9 1 है, 192 है, यहाँ पे थोड़ा हल्का सा फर्क हो सकता है, बट इन द लॉन्गर रन इट्स क्वाइट गुड. So this is just for you guys to understand. Again, when we plot this, we get the same graph. So ये this is just for you guys का reference. ये same code है almost, बस मैंने वो मैथ्स का पार्ट हटा के सीधा मॉडल उठा लिया sklearn से. Preset algorithms are ready for you. So अभी this error is quite bad, and to understand how bad this error is, you will plot residuals. ठीक है. एक मिनट, अभी के लिए मैं डाउट्स लेता हूँ. हर चीज के एल्गोस ऑलरेडी होंगे ना, मतलब हाँ राघव ऑलमोस्ट हर चीज के है. ये एक बार बता दीजिए हल्का सा. ओके ठीक है. ओके हाउ डू आई स्टार्ट इट फ्रॉम. ठीक है, अभी ये समझो बेसिकली आपके एक्स वैल्यूज है हर एक कॉलम के. करेक्ट शौर्य, समझ गया उतना? हाँ. एंड वाई इज योर प्राइस के वैल्यूज. अभी तुझे याद है तूने स्टार्ट में क्या बोला था, हम लोग 4 को एक साथ नहीं ले सकते. करेक्ट. हाँ, तो अभी हम लोग लेट से 4 को ले रहे हैं, तो वी कैन डू इट दिस वे ना, 4 अलग लाइन बना सकते हैं हम लोग विथ रिस्पेक्ट टू वाई. करेक्ट, एक ही प्लॉट में. हाँ परफेक्ट. अगर 4 अलग लाइन बना सकते हैं, तो what we can do is basically take an average of those lines and then try to get the बीच वाला line which will be your line of best fit. समझ रहे? परफेक्ट. पर वो एवरेज निकालने के लिए हम लोग लाइन को तो एवरेज नहीं करते, राइट? हम लोग एक्स वैल्यूज और स्लोप का एवरेज करेंगे. डज दैट मेक सेंस? हाँ हाँ, बेसिकली मैट्रिक्स मल्टीप्लिकेशन हो रहा है, बट एक्स टी वाई क्या करेगा, एक्स टी वाई आपका रिलेशन निकालेगा फॉर दैट कॉलम विथ रिस्पेक्ट टू वाई, एंड इनवर्स ऑफ एक्स टी एक्स विल ट्राई टू गिव इट द स्लोप वैल्यू. समझ रहा है? हाँ, अभी फिर तुम लोग के ऐसे 4 वैल्यूज आएंगे, वो 4 वैल्यूज का एवरेज इज योर लाइन ऑफ बेस्ट फिट. बस इतना कंसेप्ट है. परफेक्ट. आई होप सबको समझ गया. अभी इसमें से क्या समझ रहा है कि एक मिनट, मुझे आई थिंक कलर चेंज करना चाहिए. व्हाट कलर कैन वी टेक? रेड आई गेस. थोड़ा लाइट आएगा एंड डार्क भी आ सकता है. नहीं, दिस इज स्टिल बैड. ठीक है, सीबॉर्न हैज इट्स लिमिट्स थोड़ा. वी कैन गो विथ ऑरेंज. लेट्स सी, ऑरेंज शुड बी स्लाइटली बेटर ना. ठीक है, वील गो विथ ब्लू फिर. गुड ओल्ड ब्लू. ठीक है, हाँ ब्लू इज बेटर. तो ये लाइन दिख रहा है हमें? कैन वी सी दिस लाइन? तो ये इसको हम लोग रेसिडुअल कर्व बोलते हैं. बेसिकली वापस इट ऑल कम्स बैक टू योर वेरिएंस. अच्छा, मैं वो एक्सप्लेनेशन में जाता हूँ इसके. हाँ, रेसिडुअल प्लॉट्स ये एक बार पढ़ लो. बेसिकली क्या हो रहा है, हमारे सारे वैल्यूज है उसमें थोड़े पैटर्न्स दिखते हैं. ठीक है, एज योर एक्स वैल्यूज इंक्रीजेस, उसका रिलेटिव रेंज विथ रिस्पेक्ट टू द अदर 4 वैल्यूज चेंज इज डिफरेंट. ठीक है, तो वो नॉर्मलाइज करने के लिए, नॉर्मलाइज क्या है, हम लोग ने स्केलिंग किया था 0 to 1 का. करेक्ट. तो वो निकालने के लिए हम लोग रेसिडुअल प्लॉट्स लेते हैं. ठीक है, अभी मैं जो बोल रहा हूँ थोड़ा हैवी लगेगा, बट सी द थिंग इज, द मोर यू लिसन टू दिस, द मोर यू गो थ्रू द कोड, द मोर इट विल मेक सेंस. So before you build your own project, I would recommend going through this recorded lecture at least twice, going through the code at least 4-5 times before you actually go ahead and use it. That's it. तो अभी हाँ, इस कर्व पे वापस आते हैं हम लोग. तो इसमें और मैं जूम करता हूँ. ठीक है, अभी आई डोंट थिंक अगर तुम लोग को इसमें दिखेगा, और जूम करूँ. ठीक है, हाँ. अभी ये देखो, ये प्लॉट में इफ यू सी द एक्स, ये थोड़ा 0 के पहले का हाफ, 0 के पहले के हाफ में ये y बहुत जल्दी बढ़ गया. बट ये 0 के बाद वाला पार्ट है ना, 0 to 2 वाला, उसमें द स्लोप इज लोअर। बेसिकली आपका ओरिएंटेशन जो है आपके कर्व का, वो थोड़ा स्लोली गिरता है। बेसिकली आपका कर्व में टू द राइट साइड, टू द मैक्स वैल्यूज, द वेरिएंस इज मोर। तो अभी इसका मतलब क्या हुआ, एक मिनट, हाँ, अगर ये वाले प्लॉट में जाएंगे हम, ये दिख रहा है एज हमारा प्राइस बढ़ रहा है, तो ये जो डिस्टेंस है ना ये पॉइंट्स का लाइन से, वो भी बढ़ रहा है। समझ गया ये? लुक एट दिस, ये लाइन, ये पॉइंट देखो कितना दूर है। आई होप दैट मेड सेंस। हाँ, पॉजिटिवली स्क्यूड, परफेक्ट शुभम, पॉजिटिवली स्क्यूड। जो हूँ गाइस आर familiar with ML, positively skewed is the right term to use for this. Skewness of a data set, अगर जिनको ML आता है, तो बेसिकली स्क्यूनेस ऑफ अ डेटा सेट के लिए यू यूटिलाइज रेसिड्यूल्स। ठीक है, प्रोबेबिलिटीज बेसिक्स एंड दे विल परफेक्ट स्लाइटली, हाँ श्योर यू करेक्ट, स्लाइटली लोअर और बेंड। बेसिकली आपका जो वेरिएंस है वो थोड़ा ज्यादा है टुवर्ड्स द हायर साइड। बेसिकली आपका प्राइसेस जितना बढ़ेगा उतना दूर रहेगा वो लाइन ऑफ बेस्ट फिट से। इन सिंपल टर्म्स वही है। तो ये बेसिकली आपका एक प्रिडिक्शन मॉडल बन गया है। नाउ गोइंग फॉरवर्ड, अगर मुझे कोई भी नया डेटा पॉइंट मिलता है, कोई भी नया घर बन जाता है, एंड इफ आई हैव टू प्लॉट इट, तो लाइन ऑफ बेस्ट फिट से कितना दूर है या फिर पास है, उसके हिसाब से आपका मॉडल बता पाएगा कि आगे जाके उसका प्राइस कितना होगा। ठीक है, दैट्स इट, सिंपल। So this was, I'll stop sharing abhi. Oh, thank you for attending our event. I'll stop sharing abhi. And this was your beginning into machine learning. I'm pretty sure you guys are thoda matlab